Hello everyone, today we start new topic, lecture 6, discrete random variables and probability distributions. In this lecture, we start with interpreting the mean and standard deviation for a discrete random variable. Use binomial probability distribution to find the probabilities. Describe when to apply binomial distribution. Use hypergeometric and Poisson discrete probability distributions to find the probabilities. First, let's start with random variable. What is random variable? Random variable represents a possible numerical value from a random experiment. Random variable represents a possible numerical value from a random experiment. What does it mean? You have experiment, you make some experiment, you do some experiment, and from this experiment some numbers comes out. And this number comes from some variable. And this variable called random variable. Okay? We will learn random variables in two parts. In lecture 6, we start a discrete random variable. And in lecture 7, we will learn continuous random variable. Let's talk about discrete random variables. Can only take on a countable number of values. Example, suppose that our random experiment roll a die twice. Let x be the number of times 4 comes up when we roll a die twice. This is the variable because it will have some values, and this variable is random variable. Why? Because it came from random experiment. And let's now try to find out the values of this random variable. We roll die twice, x the number of times 4 comes up. It's possible that 4 come just in one case, in 1 out of 2 rolling of a die. It's possible that both of them 4, in this case x equal to 2, and it's possible that none of them 4. Then the number of 4 comes up is 0. So the values of x could be 0, 1, or 2. Now let's talk about tossing a coin 5 times. This is another random experiment. And let x be the number of oil-derrick side comes up. This side they mean. Let x be the number of oil-derrick side comes up. And what can be value of this variable, of this discrete random variable? It's possible that none of them this side, none of them. Then x equal to 0. It's possible that 1 just out of 5 this side comes up. Then x equal to 1. It's possible that 2, 3, 4, and 5 when possible. 5 possible when you toss a coin 5 times, and each time it fall with this side up. Okay, so the values of this discrete random variable can be from 0 to 5. Again, why this is random variable? Because it's came from random experiment. Okay, that's why it's random variable. But why it's discrete? It's discrete because you see the numbers here only integer numbers. This is also another reason. You may say that if the values of random variable just integer numbers, then of course it will be discrete random variable. After understanding discrete random variables, we can talk about discrete probability distributions. Probability distributions. For this reason, we will consider one example. What does it mean, probability distribution? Okay, for this reason. Suppose that we have experiment, and in this experiment we toss two coins, the previous similar coins. Let M represent map side of a number of map side comes up. Let M represent the number of map side comes up. Here M is a variable because it will have some values here, and I think that it will be discrete. Why? Because of this number value, of course it will be just integer numbers. That's why this is discrete random variable, because it's come from random experiment. This is random experiment. Why this random experiment? Because you cannot say its outcome before doing it. We talk about in the probability topic. Okay, now let's find out the value of M. For this reason, we should make some notes. Px, as always, will represent the probability of variable x being equal to some number. Here, when you toss two coins, you can have four possibilities: map side, map side, map side, direct side, direct side, map side, and both of them map side. Sorry, direct side. Okay, just four possibilities we have. Now, M map side comes up. In this case is 2. In this case it's just 1. In this case it's also 1. In this case it's 0. Map side. No map here. That's why in this case it's 0. Now, discrete probability distribution means that in one column you must show the values of discrete random variable or just random variable, and in other column you should show the probability corresponding to each value of x. Probability distribution. Here we will write the values of random variable, here number of map side, and here their corresponding probability. We have just four possibilities. That's why probability that map side will be 2 is 1 over 4. Why? Because we have four possibilities, and just in 1 out of 4 we have number of map side equal to 2. That's why 1 over 4, 0.25. When x equal to 1, x equal to 1 in two cases, in this case and in this case, 2 out of 4 map side comes up, and 0, it's happening when none of them map side, so 1 over 4. As you see here, we create a table, and in the table one column, first column, show us the values of random variable, and other column show us their corresponding probabilities. This table called probability distribution. Okay, but this is not only way to show the probability distribution. Another way is by graph. This graph also called probability distribution. As you see here, we do the same thing. We show the x values on the horizontal axis, 0, 1, 2, and in the vertical axis their corresponding probabilities. That's why this is also probability distribution. The third way for showing probability distribution is the formula. We will talk about later. Okay, here is some conditions related to properties of probability distribution. The first property is that probability in the table, in the probability distribution, always more than or equal to 0 for any value of x. We know this from previous lecture also about the probability. We always know that probability cannot be less than 0 and more than 1. Second, the individual probability sum equal to 1. This is important thing. The sum of probabilities in the table always 1. This is the property, important property of the probability distribution. If the sum of probabilities in the table, in graph, or in the formula equal to 1, you may say that yes, this is probability distribution. If not, you have some mistake, or this is not probability distribution. To understand it, we can go back to our previous example. As you see here, we have probability distribution table, and sum of these probabilities equal to 1. This, sum of them equal to 1. Okay, in order to be in probability distribution, you should check this rule always. If it's true, then this is probability distribution. Cumulative probability function. Cumulative probability function is one important thing for finding the probabilities. And definition of it here, the cumulative probability function denoted by capital F x0 shows the probability that x is less than or equal to x0. The cumulative probability function denoted like this and shows the probability that the variable x is less than or equal to x0. x0 is fixed some certain number. Here is mathematical definition of it. F, for example, 5 means probability of your random variable being less than or equal to 5. Remember just this definition. And how to find the probability of x being less than or equal to 5? You should add probabilities of all values of x less than this. Okay? Here is another notation. Sum when x equals less than or equal to x0, px. We will return back to this topic again, and you will understand in example. You will also understand in examples how to use this cumulative function. Expected value, one of the important things of probability distribution. Expected value of a discrete distribution calculated using this formula. Sum each x you multiply to its corresponding probability and sum all this multiplication. Expected value we sign by ex because it starts also with letter e. Same thing with the mean, the average, you know, from the topic about the describing numerical data. It's the same thing, average. But when you have probability distribution, we call it generally expected value, and you know that it's the same thing with mean. Okay, calculated using this. Now let's consider one example about it. Suppose we toss two coins. X represent number of map site. Compute the expected value of x. Here you have a table and you have a formula. We are going just multiply each value of x to its corresponding probability and add all this multiplication. Look at 0 by 0.25, 1 by 0.5, 2 by 0.25, and the result give us 1. Okay, this represents the average of a random variable x. You may say, for example, that the average of x without considering its probability, also 1. But look at 0, 1, 2. If you add up them and divide it by 3, it's 1. But it is just coincidence which happen especially for this question. Okay, generally we don't have such type of situation. Expected value take into consideration the probabilities of the values of x. That's why generally it's different than the average of x without probability x. Okay, this is just coincidence. It's never happening. It will never happen before again. Variance and standard deviation of a discrete random variable. Variance calculated using this formula. Look at here we have summation over x minus average of this random variable square of the difference multiplied to corresponding probability, and if we add all these multiplications over all x, we will obtain the variance of a discrete random variable. We sign this variance by sigma squared because here we not consider the part of the experiment. We take into consideration everything. That's why we sign it as a sigma squared, and mu represent the average. Also, because we consider everything here, all possibilities here of a random variable x, we should differ it, and instead of x bar which we use for the sample, we use mu and find the square. Expected value of x minus mu squared also gives you same formula. Okay, and standard deviation, as always, is the square root of variance calculated using this formula. Let's consider example for standard deviation. Suppose that our random experiment tossing 2 coins. X, as in previous example, represent the number of map site comes up. Compute standard deviation, and we know already that expected value for this equal to 1. We will use it here. And here is a formula for standard deviation. Let's calculate it using table. From value of x, you subtract expected value, find the square, multiply to corresponding probability. From the second value of x, you subtract the average, find the square, multiply to corresponding probability. From the third value of x, you subtract average, find the square, multiply to corresponding probability, and at the end you will obtain this answer. Average scatter of values of x around the mean, around 1, is 0.707. Sometimes instead of x, we consider function of random variable. If px is probability of px is a probability function of a discrete random variable x, and gx is some function of x, then expected value of a function gx calculated using this formula. Here you see we want to calculate expected value of gx, and what is the difference? Instead of x, we will take gx, and because probability doesn't change, we just multiply to px. Remember this formula. We will use it for homework questions. We talk about the function of x, yes? Now we can talk the case here, for example, about the linear function. Suppose that we have a, b, which are constants. Then expected value of a constant equal to a, because it doesn't change, it's understandable. and the variance of a constant is 0. Why this is 0? Because if your not number is the same everywhere, what is the difference between average? 0, of course, because all of them are equal. Yes, if a random variables always take value of a, it will have the mean a and variance 0. Remember this thing. If our function is not just x but bx, then expected value of this equal to b comes to front multiplied to expected value of x. If you already know expected value of x, then expected value of bx will be b multiplied to that number. Okay, and for the variance formula a little bit different. The variance of bx equal to b squared multiplied to variance of x. Here expected value of bx is b multiplied to expected value of x, and we may say also that if variance equal to b squared multiplied to variance of x, standard deviation of bx equal to absolute value of b multiplied to standard deviation of x. This formula, it's not written here, but maybe you understand me. Standard deviation, again, standard deviation of bx equal to absolute value of b multiplied to standard deviation of x. We consider now general case of linear function of random variables. Let x have the mean mu x and variance sigma x. Let a be constant. Then variable y, which is a plus bx, where a and b constant. Then the variance of y are, no, mean and variance of y calculated using this formula. Mean or expected value of a plus bx equal to a plus b multiplied to expected value or mean of x, and variance of a plus bx, the new variable y, equal to b squared multiplied to variance of x. As you see in this formula, in the case when we consider the variance, we eliminate just this a because it's not change the distance between the numbers. That's why we can eliminate this. And that is why the standard deviation of y calculated using this formula. You see, standard deviation of y equal to absolute value of b, because when you find the square root of this thing, you will get absolute value of b, multiplied to standard deviation of x. Let's consider example about the discrete probability distribution. In a carnival game, under or over 7, a pair of fair dice is rolled once, and the resulting sum determines whether the player will lose his or her bet. For example, player can bet $1 that the sum will be under 7, that is 2, 3, 4, 5, 6. For this bet, player will lose $1 if the outcome equal or exceeds 7, or will $1 if the result is under 7. Second, similar to the first one, but here the player win $1 if the sum be over 7, that is this, and here player win $1 if the result over 7, but loses $1 if the result 7 or under. The third method of play is to bet $1 on the outcome 7. For this bet, player win $4 if the result is 7, exactly 7, and lose $1 otherwise. Here we have third type of bet. First bet, second bet, third type of bet. We must construct a probability for all three for all three game form. For the first bet, construct a probability distribution. For the second bet, for the third bet. And the last question is that show that the expected long run profit or loss, we will determine that it will be profit or loss, that's why it's in bracket, to player is the same no matter which method of play is used. It means that in long run, we should get the same result for all three distributions. Okay, let's start solving. Let's draw the table to understand the general situation, 7 by 7, and one additional column for showing the numbers, and other all inside part here for showing the sum. These two parts, second toss of a die, first toss of a die. Here, for the first toss of a die, you can have 1, 2, 3, 4, 5, 6 because die have 6 faces, and for the second toss of a die, again same numbers. And in the inside of the table, we will write here sum. For example, 1 plus 1. It's possible that when you toss two die, you have 1, 1, and the sum of them will be 2 here. 1, 2, sum 3 here. 1, 3, sum 4 here. And the last one, sum 6, 6 here, the sum equal to 12. Yes, this is all possible sum. After constructing the table about the all possibilities, about the sum, we can go back and try to find the probability distribution for each case. Look at, for the first case, the player can bet $1 that the sum will be under 7. That is 2, 4, 5, 6. For this bet, the player will lose $1 if the outcome equal or exceeded 7, or will $1 if the result is under 7. Okay, stop here. This is first game. Let's try to find out the probability of winning here. You see, if the sum 2, 3, 4, 6. Let's go back to our table. Okay, in this table, as you see, we must calculate how many times 2, 3, 4, 5, 6 happening. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times we have the sum being less than 7. Therefore, how many numbers we have in this table? How many sum we have in this table? 6 by 6, 36. That's why probability to win in the first bet equal to 15 over 36. Look at the solution. We create a table for this. X represent the winning and lose. You can win $1, it is +1. You can lose $1, it's -1. And X is your total lose or win, okay, money. Px corresponding probability. As we say previously, the probability of win $1 for the first bet is 15 over 36. You have just two possibilities, win or lose. Therefore, probability of lose automatically 21 over 36. You may find it also from the table. We finish, we construct the table for the first bet. Now let's try to find out the probability for the probability distribution for the second bet. You see, similarly here it starts. Similarly, the player can bet $1 that the sum will be over 7. That is 8, 9, 10, 11, 12. Here the player will win $1 if the result is over 7, but lose $1 if the result is 7 or under. For the sum being more than 7, we have these numbers inside of this red rectangle, and as you see here we have also 15 possibilities. That's why probability of win second bet also 15 over 36. So probability distribution for the second bet similar to the first bet. You may win $1 and probability of it 15 over 36. Probability of lose $1 is 21 over 36, as in A. Okay, similar to A. Actually, yes, similar to A, same thing. Now let's consider the last part, the third case. A third method of play is to bet $1 on the outcome 7. For this bet, player can win $4 if the result of roll is 7 and lose $1 otherwise. The sum that satisfies the condition when the sum is 7, just these possibilities. How many possibilities we have? 1, 2, 3, 4, 5, 6. That's why probability of win, the third bet, is 6 over 36. Then automatically lose will be 30 over 36. You see, we construct also probability distribution for the third bet. You see, we win $4 if the sum equal to 7, and we calculate from the table that it's 6 times happening. So 6 over 36 is the probability of winning, and probability of lose is 30 over 36. Here we finish probability distribution of all 3 bets. Now let's show that long run profit or lose doesn't matter which play is used. For this reason, we will calculate the expected value for all 3 distributions and show that they are equal. To calculate the expected value for the first bet, we multiply -1 by this plus +1 multiplied by this, and it's equal to -1 over 6. It means that long run loss for this bet is -1 over $6. Similar situation we will have for this. Again, this multiplied to this plus this multiplied to this. Again, it's equal to -1 over 6. What does it mean? It means that long run loss for this bet also -1 over $6. And it's interesting that if you will do the calculation for this case, again you will have the same result. Let's do it. -1 multiplied to 30 over 36 plus 4 multiplied to 6 over 36. It's give us -6 over 36 if you add up these two multiplications, and it's equal to again -1 over $6. What does it mean? It means that the long run loss for all 3 bet is -1 over $6. -1 over $6 is approximately 16 cents. 16 cents. And what does it mean? It means that the pupil or the person who make this game, he know from the beginning that generally people will lose this game. Some people win, some people lose, but generally they lose, okay? And what does it mean? -$16. What does it mean? It means that each person here, average, the lose for each person is 16 cents here. Doesn't matter which play you choose. From each person, they will take approximately 16 cents. Okay, and it's used. The government also use this thing in order to put some tax for the lotteries. They know from the beginning that what is the average money taking from each person. Okay, by using statistics, by using probability, they know beforehand what this lottery will take from each person, and knowing this, they put some taxes for this. Okay, and you see all three games equal here. Their expected values for all three bets here equal. Maybe it means that the tax for each one, for each of this game, equal. Okay, for each method of play, yes, from each person, it's interesting, they will take this game take averagely 0.17 cent.